In 2015, Bruno Latour traveled to Duke University to think about the idea of the critical zone. And he came at the invitation of a critical zone scientist, Daniel Richter, who's with us today, and others, Saskia Cornes, Barry Saunders, Christine Folch, traveled with Dan and Bruno to the John Calhoun Critical Zone Observatory in rural South Carolina to observe how deep soil erosion gives a more nuanced view of the Anthropocene. Now, in the humanities today, we know quite a bit, in fact, surprisingly enough, about the Anthropocene. We've been thinking about it quite intensively over the last some years. And one of the philosophical problems that has arisen again and again is an understanding of scale and how the human is both called upon in Anthropocene discourse to be a responsible, active individual on the one hand, and then on the other hand, having to deal with questions that are far beyond any one human's intervention, beyond any understanding of human scale that we can actually think through. I mean, I'm interested in how the critical zone is a political concept as well as a scientific concept.
I think that's one of the reasons why Bruno had an affection for the Calhoun Critical Zone Observatory, because here the politics is arrayed through time, through historic time. And cotton in the 19th century is right in the middle of this landscape still to today, even though cotton was no longer growing in this part of the world for over 100 years. Yet the legacy of that is still active and ongoing, and not only in the people and the local communities, but of course, but also in the land and the way the land functions. We have 50-foot gullies from the cotton, the erosion of the past, a landscape that is called the worst of Piedmont conditions because of that environmental history. So even where Duke is, we're surrounded by eroded soils, but here there's something almost an whole order of magnitude more erosion. It's almost unimaginable as the human history is in the same landscape. Unimaginable, and yet it's only a century in the past, but it's very political. It's a political landscape.
Dan, I'd love to hear about your first meeting with Bruno.
So we were working on the critical zone science project for probably a decade, and getting our National Science Foundation to give it credit, and then to put resources into this program to fund observatories, place-based science work. And so I sent them an innocent email, like 2 lines. Congratulations, thank you for speaking at a geochemistry conference. And then I got an email back from him, just like out of the blue. And so in some ways it was accidental, in other ways it was just definitely part of our time that I was able to do this. But then I realized this was really special, to have a philosopher of science, to pay attention to science the way he was. And so I started to encourage my colleagues in the United States, most of whom had never heard of Bruno Latour, that they should invite him to their observatories, because that's what Bruno wanted to do. He was on this mission to go from observatory to observatory. He really wanted to come to the Calhoun because of our historical degradation of the land and its inhabitants, and that is the cotton culture of the 19th century and its aftermath. But he immediately I had never met him before. He got out of his van, and it was like we were friends, and instantly. It was so wonderful. His personality was such that there was a lot of humor, of course, but also an approachability and a curiosity on his part with everyone, student or professors.
You know, the warmth that you describe is palpable in the film, and it seems to also come from a kind of endless curiosity.
And appreciation for the beauty.
Yeah.
Even though we're living in the Anthropocene and we're
Right.
looking at a critical zone observatory which has been crippled, not just the land but the communities there. And there are people who deeply love that landscape and will not move. You know, African Americans and white Americans, they will not move. They love that land so much, and there is a great deal of beauty in it, and it's very particular. And so what I think Bruno grasped was the particularity of this critical zone science. It was not only getting all scientists and indeed humanities scholarships together, but it's all of us to study the same place and to do so over years. Yeah. So in the late 90s, one of Bruno's many books was published, Pandora's Hope, and it's a collection of essays subtitled Essays on the Reality of Science Studies. And he opens chapter 1, Do You Believe in Reality, is the title. There's lots of marginalia of me trying to cope and trying to grasp what is going on here. And somehow he got his hands on it and wrote a little inscription. And I never did understand this because his handwriting is not very legible. And so I took a picture of it last night, and just to say, looking forward to today's conversation. And you translated that, so to speak.
I did. This book never had such a kind and searching reader.
Oh my gosh. What a wonderful thing.
Yeah,
Yes.
no, it's lovely. It's lovely. You know, I feel like, you know, like the nurse can decipher the doctor's handwriting. The student of French critical thought can maybe decipher the handwriting of the French philosopher. But yes, no, it's a beautiful message, and obviously he appreciated the care with which you thought through the scientific implications of the philosophical work that he was trying to do.
You know, he was deeply sick for at least a couple of years, and yet he kept going. And I don't know how he did that. I mean, he kept having exhibitions, you know, and this book came out, and oh my goodness. What a wonderful mentor that we all have.
Yes, yeah. Well, I hope you all enjoy the film made by Eric Barstow. I think it's a really lovely evocation of the man, Bruno Latour, but also of the idea of the critical zone that has been so important to our relationship with him at Duke.
Yeah, it's so much easier that way. Yeah. That's what Calhoun did for. No dilly-dallying.
Yes. And you know what works really well on really bad bird? What are we doing?
The Anthropocene is a moment in history. Critical zones are places and sites which then prove or disprove some of the interpretation given to the Anthropocene. So the Anthropocene is a very global term that covers the whole Earth and at very specific moment. And critical zones are small spots on the skin, if you want. The critical zone allows to give to have a handle on the Anthropocene. I think the Anthropocene is, of course, one of the reasons why we are so interested, but it's not the main. The main is to understand this interaction, which would have been to be understood anyway, even if the Anthropocene had not occurred.
We love the exemplarity of the bus ride to the critical zone with Bruno Latour as a means of getting the humanities out of the box, mobile, living the surprising, if specifically not good, adventure of the Anthropocene.
The Anthropocene is the new geological era that we find ourselves in when humans are the primary drivers of geological forces.
There's a lot of different people that are giving their best mental facilities to understanding what is the Anthropocene. The history of the Earth has been named by stratigraphers, and what they're after is they're looking for a point in the landscape, a strata, and it has very little to do with the history of humanity. It has everything to do with a very practical decision of finding a place that is global in scale and relatively synchronous in time, so that worldwide we can all say, oh, that's the Anthropocene boundary. Of course, the bigger question of what is the Anthropocene is so much more interesting, and that involves all of us.
What it means to be on Earth in this moment, but actually what it means to be human in this moment. I think one thing the Anthropocene redefines is what it means to be a member of this species. Humans having a profound impact on all of Earth's systems, including climate. We're not just talking about abstract systems that may or may not impact us, but a fundamental shift in human identity and how we hold that.
I think it's really important to parse out who it is that we're talking about when we say the Anthropocene describes human impacts on the planet. Because if we're not actually careful to talk about history or politics or society, then we don't actually understand how we got to the situation we're in, and we can't then address the problem. If you don't understand the history of an issue, you can't solve it.
On one hand, there's this human-centered view. There's a nostalgia for the garden that echoes within the speaking of the Anthropocene. On the other hand, there is a non-nostalgic, the chapter of human life on the planet is closing. Sucks for the humans, but here we go, what's next?
Where else to begin a scientific investigation within the Anthropocene except at a local scale? The global scale is nothing if not an accumulation of little places all together, countless places, and countlessly diverse places also. The world is so diverse from one place to another.
I see critical zone, but again, I'm not the specialist of critical zone. I have absolutely no authority to speak in the name of critical zone.
Who is Bruno Latour?
Oh my. Yes. Who is? Yeah. Yeah.
Eating barbecue with Bruno Latour in rural South Carolina. That's not a very profound answer.
Maybe we should have water. Take water here. It's going to be tough.
I always just imagine somebody very severe, very high theory. And in fact, he was so delightful.
Bruno Latour is, of course, one of the most innovative thinkers of our era. Duke Earth scientist Dan Richter brought us philosopher Bruno Latour, and we anticipate a long humanities partnership with Dan.
The education of Bruno Latour. So I was reading The Education of Henry Adams the summer before that, and I had heard about Bruno really being excited about critical zone science for a number of ways, and picking it up from a philosopher's point of view. It occurred to me, maybe we could invite him to Duke and we could call this whole enterprise The Education of Bruno Latour. What a giant idea that was. So I carefully asked him, could we do this under that? He said, so be it.
Are you for the 1610 date for the Anthropocene, or you think this is a big disputed? Have you written against it? Or?
Here's a paper.
Yeah.
And so we all got in that van, and it was a couple of students, a couple of grad students, who were very active participants through the whole 2-day trip to the Calhoun.
If the stratigraphers require global scale for their naming of epochs and so forth, there are scattered bones on all continents that can be found over time and pieced together into a pretty interesting stratigraphic, narrow-minded stratigraphic story of when the Anthropocene began.
I like the megafauna extinction argument.
So Bruno, Matt and I are really enthralled by what's called the late Pleistocene extinction.
So we're talking 12,000 BC.
Basically every continent we got to, all megafauna above a certain 100 kilograms, let's say, die. In terms of thinking about like fundamental changes to the Earth systems, thinking about megafauna extinctions caused by humans is another way to think about like more of an actual beginning for me, at least. In Madagascar, all these islands that we get to, Australia, and then all of a sudden, like just very quickly after the humans get there, all the megafauna are gone. And there's a lot of reasons that has massive impacts on soil much later.
I don't know if we want to just date the Anthropocene to the very first moment that humans started using tools to manipulate their environment, and I'm uncomfortable with the politics of that. I think of the Anthropocene as very tightly tied to capitalism and through the intensive use of resources. So
the most interesting, in my view, is the Anna Tsing argument about plantation, and that there is something completely strange into the building of plantation, which is then used for coal and capitalism proper. So the problem is, if you want to capture this dip, the idea that from the very beginning we were killing animals and transforming our environment look a bit a way to whitewash the whole of the history. The question is, how much history do you capture with the argument?
When did the Anthropocene start? Not all humans have acted in the same way on the environment. Conceptually, that's one of the challenges of the term Anthropocene, because we haven't talked about who the anthropos is in the Anthropocene. Who is the human who has done the stuff that has these sort of global impacts? And who are the group of humans who are disproportionately feeling the impacts? No matter where different scholars are putting the date, they're describing a certain set of activities that are in general most closely associated with European colonial expansion and European industrialization.
When we speak of nature, we speak of cause and effect, as if the mechanism was very simple, as if once you have a basis, then basically you have everything else in addition. And actually the original paper, which is at the start of the critical zone paradigm or concept, is a paper that shows the difference between what the chemistry would predict in the lab and what you would observe in the wild, outside.
One could make an argument. Let's retreat to space and just watch the Earth as a big object change. But I think that we all have to live places, and we all have to eat from places, and we all have to interact with the Earth in some fundamental way. It's in our bones or in our DNA. The slogan. What's the slogan? It's a big ecosystem. It's big. It's an expanded ecosystem. So the slogan is treetop to bedrock. So that means from the plants to the deepest weathering zone, the deepest biological signal that's penetrating the Earth, that moves through the Earth. It also could be described in fluids, kind of as in some way, from the climate, the fluids of the atmosphere, all the way down to the deepest aquifers. The Critical Zone Observatory gives us a real chance to dig a lot more deeply into a particular place and where humans have had a substantial effect over time, over maybe even thousands of years or just a couple hundred years, and to look at the diversity of ways humans are interacting with the environment and the diversity of ways environment is affecting humans.
So in that sense, contrary to many sciences which bring what is outside in the laboratory, the critical zone are interesting because they bring the lab out, so to speak.
What is the connection? What is the direct connection of an individual locality and human effects on the individual locality and the globe? It was purposefully meant to be interdisciplinary, but it was written by a team of Earth scientists. So what did that mean? It meant that Yeah, the hydrologists should get together with the geochemists, should get together with the geophysics people, or the biogeo people. Darwin couldn't have been Darwin without who? Sir Charles Lyell. He took principles of geology with him on the boat, on the Beagle, and read it carefully. And without that the first realistic history of the Earth, Darwin couldn't have begun to do what he did. We have this 19th century very integrated view of science that we think that critical zone science proposes us to come back to. Because what happened in the 20th century is we got the building of universities and research labs, and people got narrower and narrower. Scientists got narrower and narrower in their viewpoints. It's like the 19th century, I think, correct me if I'm wrong, had a fluidity about the scholarship that was lost in the 20th century when departments became entrenched, disciplines erected boundaries, literature, journals. We all know that story. We all are growing up in it, but the 21st century doesn't have to be that way.
Well, so it was Dan who introduced me to critical zone science. This wasn't something that I had familiarity with before. As soon as he started to explain it to me, it made a lot of intuitive sense, not just as a humanist, but actually also as a farmer, and thinking about the ways in which we can talk about human impacts on the earth over time using this what was for me a completely new vocabulary.
We're pretty much in the dead center of this image. What are we looking at here? Light is elevation. Yeah, in this case, this is elevation map. This is an elevation map. Look at the land in 1933. And if you don't get lost in the detail, if you keep moving, you can put on top of that 1933 image this LiDAR map we were just talking about, match the gullies to the farms, and there's such a richness there that's open to us, even though there's a lot of hurdles as well. And so we're really interested in moving this landscape back in time to better understand how people really did impact it. The plow is a very violent instrument. Whether it's 10,000 years ago or yesterday, the plow is a very violent, it has a lot of violence to it in terms of mixing the soil and potentially making the soil erode away if it's not cared for well.
The land was broken. Roots picked. The land plowed and disked, left bare, ready for crops, ready for erosion.
The southeastern United States is one of the most erosive environments, and the 19th century development of agriculture here, 20th century as well, led to some amazing erosion that is world-class, so to speak. Especially in the Piedmont, the cotton grew and then collapsed, tobacco grew and collapsed, rice before that. A number of crops grew very prolifically out of the native capital of the soil, but then collapsed economically and environmentally. The Calhoun Experimental Forest, the federal government bought up the abandoned, very degraded landscape, 200,000 acres or so in the 1930s, and forests have been able to regrow since then. The land is regenerating with trees and of different sorts, but it's hardly recovering. So I want to get to page 7 and think about the Tiger River, but think about the Atlantic riverways through time. So we're thinking about a river through time. These rivers will carry sediment for hundreds, if not thousands of years, well above wherever they were in the natural system. The river has aggraded to the point where these floodplains out here are historical, post-alluvial, they call it post-alluvial settlement, so very much historic soils, and they can be seen on the LiDARs and so forth, and that's what we're talking about here, that issue. Anybody have boots on? Anybody, can I convince?
Shoes off.
Really?
Sure.
Oh my gosh, we're going to send a medical doctor across the river to do soil pedology work.
Awesome.
This
that bit. We'll go for help if you need it.
Yeah, absolutely.
If it disappears.
How's the water?
What did we do here?
This is science.
Yeah, it might fill up, so you might have to go to a. We'll have to see how we do. So what we need is we needed to have brought what's called the Dutch auger, which doesn't capture the soil in a barrel. It's just a corkscrew, and we could have Dr. Saunders just go all the way down and demonstrate. Yeah. Do you think the hole would maintain its integrity if you pulled it out, or would it just fill in because the sand is a liquid?
It's pretty liquid.
Yeah.
You have been heroic, Barry. You have been heroic.
Yeah, very heroic.
So this is classic bed load of a river. It's really the coarsest, biggest particles that are picked up only occasionally and moved down in a very discontinuous process. There's lots of mica in here. It's really shiny.
This is how we pay for the expedition, huh?
Yeah. Lots of mica here. Yeah. Because much of this landscape, that's especially in the national forest, is relatively stabilized.
You said erosion is still going on in the Goodies.
It is. It's surprising me. So we dream about how we want this project to grow, and we can definitely grow it upstate.
Yeah, I brought two as well.
But I want to move it downstream, because downstream is one of our newest national parks, one of our newest national parks, right along the river, the Congaree River. And our hypothesis that's being borne out by some of Tom's colleagues is that a lot of that sediment is historical. And yet the way that national park got organized was the trees are so magnificent and beautiful and huge. It got launched as a pristine project, pristine forest project. And it has a lot of value to it, there's no question. But how much more interesting than that is the sediment that's no doubt a big part of that, the way that system has responded and has coped with stresses. Yeah. Our rivers in the Piedmont are loaded with 19th century sediment that eroded from the land, and they will continue to contain that sediment for hundreds of years to come. Right now we have 9 observatories, and there are 9 environmental issues that each of us are beginning to try to address. Calhoun is trying to address erosion and the many centuries effects that erosion has from agriculture.
The people who were on the trip were themselves interdisciplinarily disposed, so people were able to speak outside their disciplinary languages.
I wanted to talk in kind of an experimental way about this state park we're at, Rose Hill, the relationship of the critical zone to the state park. And in the New Deal, they employed artists, writers, photographers, and so forth on these little expeditions. And one of this group of people were writers, and they interviewed people. And a lot of those projects were in the South. And these writers came south, and they interviewed in 1930s ancient people, the last of the living slaves. Amazing. A marvelous story. It's about Jack. And Mary was the teller. She's very old. She's telling it. And it's telling about Jack, who was a fellow slave on this Rose Hill. And she tells about Jack's escape to his cave. And in the 19th century, gullies were not infrequently called caves. Jack found a cave within sight of the local road, which has a bridge, and the same location has the bridge today, and hid out in the cave for 6 months. And she said he put a fence up and collected animals from the woods. He had a couple pigs and I don't know if he had cows, but he had chickens, and kept himself safe for 6 months or so in his cave, Jack's Cave. So he calls this little essay Jack's Cave. And he also says, this is a critical zone story. And I thought, wow, that's very special. Because he had to make his way through the forest and across the river and so forth. Well, eventually, 6 months later, he was found floating across the river on a log. Somebody spotted him from the bridge or something. And the overseer was taken down there, Jim says, or Mary says, and they brought him back here and they whipped him and they, quote, whipped him and put him back to work. And so that's Jack.
How is it a critical zone
Jim's
story?
Well, that's a good question.
It's very difficult to find stories which are not critical zone because apart from things which happen in the space station, and even there they are still related to Houston. So actually we have no other place than critical zones to breathe.
Obviously, when we're talking about chattel slavery in North America, right, this is a racialized caste system, right? And so it's clearly like white and black. When we're talking in Europe, it's not a racialized caste system, but it is a class system. And so you're talking about elites in Europe and the masses in Europe. I think one of the things that's tricky about the concept of Anthropocene is that it faults humanity for these changes. And it's actually really clear when we start talking about history that there are unequal power relationships at play.
I mean, I think we're all used to the idea that we can have massive impacts locally, but I think it is a brand new epistemology, a brand new way of knowing, thinking about knowing, to imagine ourselves as a geological force, as a planetary force, as a species that's affecting everywhere at once, not just the places that we are, the places that we can see. We're having an impact for better or worse, but on systems that we can't see, like the climate and geo-earth systems.
On the timescales that most of us work, I think it's possible to have local, partial, claw back a little bit of quality of something, right, that resembles how things were a decade ago or a generation ago. I don't know that that's possible on the planetary scale.
Can't we make a difference now? Isn't there a way to turn the ship around, so to speak?
I'm going to be blunt. I think that the human influence layer is fucked. I think there's rapacious greed, right, that's eating up forests around the planet. There's no form of regulation or how can people not cut down the last tree, right? It's so the view of that has a Lorax running around trying to fix things is at one level sentimental and well-intentioned, but I think it's too little, too late, not. So I don't really hold out hope.
Oh, yeah. We should. Oh,
what happened?
Here, look, you have some fire ants, so I'm going to brush them off. Oh yeah, they're really beautiful. Yeah, they're already. Their species, I think, is named bellicosus. So I will show you one. So if you look at them carefully, their mouth parts are huge relative to their body. Okay, there. He's trying to get us. So what they often do is he's got me. What they often do is they swarm you, and then in one moment they all do what he's doing. He finally let go.
It's their planet.
Yeah, it really is. So why don't we go from top to bottom, and then you take over.
Top to bottom?
Yeah, surface to deep, whatever.
Run through all of them, all the depths, or just talk about it? Because we've got 2 wells in now here.
Yeah, let's go to 3 and then 5 meters.
Okay.
Yeah.
Yeah, so we, in most of these site comparisons, we have installed gas reservoirs that are exactly like this, going from 50 centimeters to 1.5 meters to 3 meters to 5 meters. Maybe I should approximately turn around. I don't know for for people to see what I'm doing here. It's not a mystery cooking show. So we auger out, drill a hole with human power to our desired depth, and then we hook up the lines, power on our little devices. So our oxygen meter right now, it's just reading ambient oxygen concentrations. It'll equilibrate. Atmospheric oxygen is around 20.9. Atmospheric air is 20.95% oxygen. There's a small amount of dead space of air in the pump, which it's nice to get rid of because it's a potential source of contamination because the air above the ground surface is different from below. That's the whole premise of this. So we run it for just a few seconds. I have a timer for 1 minute. I start that, and then what we're doing is we're just cycling the gas through all the instruments. So here at 3 meters, we have got something like we have decreased to 17.5% oxygen. So we've lost just about a little under 3% oxygen at 3 meters depth, which is very indicative of the kind of environment that we've got down there.
So below ground, the air is not very well mixed like it is above us. It's pretty consistently the same concentration above us. Even with a little bit of wind, it's enough mixing above ground. But below ground, the mixing is much slower. Certainly the solids aren't moving around as rapidly as the molecules above ground. But the pores, it's about 50% pore space below ground and 50% solid. But the pores are interesting because they're very tortuous. We were talking about the pipes that larvae and earthworm makes. Those are macropores. Many of the pores are very tortuous, and they end with dead ends and cul-de-sacs. To exercise my French, what little there is. But in any event, it's not a well-mixed environment, so we're going down 3 meters, and these CO2 molecules have very long residence times. They're not in the soil surface being created by these earthworms and so forth and leaving very rapidly because it's only a foot or 30 centimeters. But we're 3 meters, so the diffusion rate from 3 meters is very slow, and thus that's why the CO2 builds up, and that's why the oxygen down there potentially collapses. But over time, over the seasons, and maybe into the 2nd year and 3rd year when others of us will pick up this record, we will see the ebb and flow of the respiration and the collapse of oxygen in the summertime and the re-equilibration as oxygen diffuses down below ground in the wintertime.
We're also interested in methane and nitrous oxide. We want to have a sample of some of this gas. So we have our little pre-evacuated gas bags here, and we fill them up, not to bursting, and we take them back to the lab for more detailed, more nuanced analysis.
Last but not least, maybe you can get a little glimpse as I catch my breath of these multiple colored iron features. And so a little bit deeper, we start getting multiple colors of iron. Thinking I might give this to Christine to finish banging out.
So what am I trying to do?
If you can just clean up and make it a little deeper. That's all. A little bit at a time.
Good Lord.
I like the broad end is a little better.
Okay, well, I don't know.
This pit, I think when we first sampled it in the mid-90s, was 3 meters at least. So it's filled in really extremely. So we're looking at maybe the upper 2 meters.
But if we let Christine work, it will not. We can dig it again.
That's right. for the rest of the
In
day.
a couple of hours, we will be down to 4 meters.
Yeah. You can come up for air now.
Oh, it's still an aggregate.
Isn't it?
It's not stone yet.
No.
Yeah, it's dry and indurated. When it's dry, it's indurated. It's rock-like almost. Very.
But it's still clay.
Yes. There are basically two end members here. The iron depleted, the white or the gray or even the yellow, the iron depleted zones, and iron enriched. So the iron has moved from the iron depleted to the iron enriched. And why might that be? Iron enriched is oxidized iron. It is one of the most insoluble compounds on the Earth. Iron oxidized is very insoluble. Atoms move from high concentration areas to low concentration areas, and so it travels that concentration gradient. It's simple as that. It's the same thing here. Iron is reduced, it's most concentrated, reduced in the depleted area, and it moves toward the oxygen where it's oxidized and it stays.
I see hair.
Yeah. So where
Or
do you
maybe
see
it's a
hair?
root.
Where do you see fine roots?
In the part that
Iron depleted.
the iron depleted
I
part.
didn't tell you that. I didn't tell Christine that. The roots are only in the iron depleted zones.
Oh, I'm sorry, Bruno. It's in your pocket. I don't know what it is.
Sorry.
I beg your pardon.
No problem. No problem. So we have the growth of roots down here, and they're mainly empirically we can see they're mainly in the iron reduced areas, the iron depleted areas, and so organic matter as it decomposes consumes oxygen and forms CO2. Well, what happens when oxygen is not freely diffusing down into the decomposition system? Oxygen will run out, especially near the sites of the roots, which are demanding aerobic respiration to go on, but they run out of oxygen. So the most prevalent electron deficient element next to oxygen is iron.
That's what you were saying.
Yeah.
This is what you were, yeah.
Oxygen is very electron deficient. In order for the energy system of our bodies or of the soil to complete itself, electrons have to flow. And when a sugar oxidizes to CO2, an electron flows to oxygen. Well, here's an environment where there's no oxygen. So the respiration is probably slowing down because of the water, but it's still going. The microbes demand that respiration go on. They want to live, and they're switching their electron acceptors. And the most prevalent one here is iron. Most prevalent electron acceptor.
Next one after oxygen.
After oxygen, the most prevalent.
But
yes.
why would that concentrate them in one layer?
Oh, that's the mystery here.
Ah, okay.
Yeah. And not only that, it's horizontally displayed. These tiger stripes
These things right here?
are very horizontal. You get this horizontal structure. I have no idea how that formed. That's part of the nature of our sciences. We don't understand everything. It's nice to have some mystery.
You are very good at bringing agency into chemistry. Can you do the redox?
It sounds dangerous. This is one of the hardest things to describe that you ask. So most electrons flow in the energy system through oxygen. Let's say that. And so that happened, what, Bruno, 2 billion years ago. All of a sudden, finally, the plants generated enough oxygen to make it an oxygen-rich environment.
That's a great pollution, a great catastrophe.
Yeah, kind of, yeah. Crisis for the anaerobes. Right. And it's really interesting, before that, all of these anaerobes, all the anaerobes retreated. Where did they retreat? Down deep. Their metabolism is much slower than the average aerobe like you and me. And so it's particular environments like wetlands or deep in a soil that doesn't freely aerate that there's this anaerobic respiration. And this is a zone that's really interesting because that same volume for much of the year has oxygen in it. And then for other parts of the year there's less oxygen, and so the electrons flow through iron, and respiration in life flows through iron. I love that idea because we usually think of geo and iron as abiotic or something, but It's a very life-supporting process that we're talking about. So this system actually moves from an oxygen-dominated respiration to a non-oxygen-dominated system within every year.
We ebb and flow.
Yeah, ebb and flow. Yeah, ebb and flow.
You still washing dishes? And I said, yeah. He said, if you write this guy a letter, he'll...
We have a part which is, I find interesting in the critical zone. The humans is not a layers added to land, which would be defined by physical property. So in that sense, it's fairly different from the classic discussion between, let's say, physical geography and human geography, to take an example of another, or physical anthropology and cultural anthropology. It's not a layer. The human appears, as we saw in the field, as a certain way of transforming the soil or making the soil disappearing, a certain way of adding phosphorus, a certain way of letting the nitrogen move around, and so on and so forth. So it's a great advantage for the people in the social sciences, because at last we get a sort of different, more realistic definition of what a human is. And not just as a human added to land, and as if the land was just a backstage on which you put, as if you are in a theater, and then you have a theater, and then you put the human on top of it. So this redistribution of agencies goes both ways. It goes for the definition of nature, which is multiplied, and on the definition of human subject, if you want.
Critical zones also help us to conjure the psychotropes that modify who we are, getting us all mixed up by making our souls spin, to paraphrase from Latour's inquiry into modes of existence. So welcome to Bruno Latour and Dan Richter.
This is Bruno's research trip. So when he proposed to visit the Calhoun Critical Zone Observatory, I said, we have to do a day at Duke. And Bruno said, no lectures. Basically because he professed to be a student, which he is, of what we think of as a new 21st century science, critical zone science. It's a view of science in a different way in terms of data. And it means that a critical zone science means we share our data. We're not like hyper protective of it. We're looking at the same system from different points of view, different disciplines, and it's really almost incumbent that we share our data with our colleagues. And that puts the whole scientific enterprise in a very different frame of reference, I think, from one of hyper competition, protect my data before I'm not going to share it before I get my paper out, to one in which data are shared and we're all studying the same system, so we're all going to advance together as a team, as a little community. But how else are you going to kind of take advantage of these other disciplines if you're not going to share your data as they come online and after you demonstrate their quality? And we're very interested in the metabolism. We all have metabolism, a metabolism as organisms, but the Earth has a metabolism too, and it's highly organized, and CO2, carbon dioxide, just like we breathe into the air, is liberated to the soil atmosphere and has a very...
Can I make a brief announcement?
Yeah, announcement.
Sorry, so I'm Beth Perry, Program Coordinator at the FHI. I've just been told we're going to have a fire drill shortly. We tried to get it canceled, but so we will have a brief interruption.
Is that momentarily?
I think pretty soon, yes.
Okay, so we can handle that. That'll be our hard transition. Okay, let me try to finish up here. And we can map the topography of the bedrock. I've already said that. There it is.
This work is so interesting to me, right? Is thinking about soil not as an inert substance, but thinking of it as a very much alive thing, right? You feed the soil to feed the crop.
So these are plants that had a huge impact on Durham, a massive impact on Durham. So this is actually sorghum, which is
sorghum.
What was grown in America before
corn.
Before sugarcane. Before they developed...
So this is not corn at all?
No.
Ah.
No. It is a grain, and it's used as a grain, I believe, in parts of Africa. But in America, it was used solely for sugar production. And actually, in this area, you can still find... When people talk about molasses, local people, they're often talking about
Sorry,
sorghum
trying
syrup.
to get simultaneously. I don't want to
I
be
don't know, I can't
polite.
tell if I'm supposed to be in or out
No,
of the
no,
picture.
I want you in the picture. And the sorghum. Okay,
Yeah.
this is sorghum. I've heard of sorghum, never seen one.
Yeah, and cotton. Specifically, we grow these white varieties of cotton, but also these colored cottons.
Where? Cotton?
This
Finally,
is what
when I
cotton
see some
looks like.
cotton. This is cotton?
Yeah, so it's a beautiful plant. You can see the bolls forming. This is where the actual fiber will come from. And obviously it's kind of maturing from the bottom up, so this is the flower and the immature flower bud. There was a class here before us who's studying this. The land that we're standing on was a former plantation, like so much of the land that we were at this weekend, yeah. It was farmed pretty continuously until the 1970s, which is one reason why the soil is so awful. You can think of this as like a plant that's really reaching back all the way back to plantation days, and unlike other kinds of artifacts, right, it must have been planted continuously in order to have survived.
So you got the sugar? This is how you do the sugar?
I think in sugarcane, the sugar comes from here.
And not from here. Okay.
But I don't know.
When you're farming, you're so focused on the upcoming season. How are the crops responding? How are they doing? How is the soil responding? How is it doing? But you're looking at it on a season-to-season basis, on a cyclical annual basis. And you can see, and we've already started to see, given our stewardship practices, some minor improvements in the single-digit percentages to our soil health.
So we're talking about alchemy and how there's so much nitrogen in the air, and this is it coming
that's a
below
little
the soil.
nodule,
Yeah.
But to be able to see those impacts accreted over not just decades but centuries through the CZO was really profound. The kinds of damage you can do over a period of time, and that being a really palpable microcosm of this macrocosm that is the Anthropocene.
It's like a beach. Yeah. There's nothing there.
This is why we farm was abandoned?
Yeah. You see, it's basically just pure sand.
This is amazing.
Yeah.
What will grow in this, if anything?
Horse nettle seems to grow really well, which is that's a perennial weed.
In terms of farming in the southeast, about 300 years getting ourselves into this mess, and to think that maybe in 300 years, if we're still around, we might be able to get ourselves out.
One of the key concepts of Western thought is that nature is a resource. And that is not how all groups of people imagine and understand nature. Now, when nature is conceptualized as a resource, the question is, how should you use your resource? That posture towards nature lets us imagine certain things and do certain things like, well, if nature is a resource, then what we're supposed to do is extract it and use it for ourselves, either for industrial use or for pleasure, like, oh, I really like nature walks, so I really want to make sure the forest is still there. Other groups of people don't conceptualize something as nature. So we think of ourselves as separate from nature, and nature is a set of resources. Many human communities, including human communities in Europe prior to, the 1400s and the 1500s, imagine nature as a set of relationships. These are just, you have a relationship with the land that you're on, you have a relationship with the water, you have a relationship with the tree, you have a relationship with the plants. This is all part of a web of relationships. And if you're in relationship with something, then ideas of reciprocity come in, which means that if you take, you give, etc. The inequalities that are contained and hidden sometimes in the term Anthropocene, it's really important to understand that not everybody views nature the same way, and not everyone has used nature in the same way.
I'm interested in the link between laboratory and field, basically. So critical zone is interesting because it's not a case where you bring the outside in the lab. On the contrary, much of the work is trying to take the lab and bring it in the field and transform the field into an instrumented, what I call intensive unit care, so to speak, for the earth soil. And that's interesting also for political reasons, because in a way, health is very developed and soil is very little developed. We were walking through the medical school here, and I think it's insane to see how much building they have, this guy in medicine. Buildings after building after building after building for our health, which is fine, but what about the health of the soil and of the planet? There are not that many buildings for that. And so there's a sort of a complete imbalance. We take enormous interest in our body, which is of course understandable, but see, this is small equipment. We know very little about the outside and what the earth is made of.
So you find that analogy to be helpful, the sick patient and the earth?
I do. I see a place where the analogy ceases to hold. How do we know that the ecosystem is sick? We do this work of anthropomorphizing and projecting, right? It's sick for us. I think that was part of his argument was, and what he's written on is this game of attribution of agency, right? It's not sick for Gaia, it's sick for us. But there are lots of ways that we treat the slime layer on Gaia as if it is sick, and are committed, deeply committed to chronicling and mapping voxel by voxel, right? Its decline, its slipping away from some Edenic state.
Physiology is derived from pathological states, which are derived from the felt experience of illness, right? So it all begins with the complaint, with the perception that this is screwed up. It's the forest crying out, like the patient crying out, that becomes the motive for disciplines. I mean, Bruno began with instrumentation, right? We have so many instruments in medicine, but it's to populate this zone of complaint.
As an ER doc, I was aware, sometimes painfully aware, that most of the people who came through would have done just fine on their own with duct tape and spit. It was a very small number of people who had bona fide emergencies, whose lives were prolonged or materially helped because of something that I was able to do in the emergency department. In my teaching of medical students, which is in a interdisciplinary humanities, social science kind of seminar space, I always challenge them early on by, asking them if we do anything to change mortality, right? Mortality is always 100%. And then they say, well, maybe not mortality, but morbidity. We are sure that there are places where we create new morbidity. It's not clear that we reduce suffering. This ambition that most medical students have and write in their applications, right? I want to reduce human suffering, is already a kind of naive hope. So you might argue that's a kind of nihilistic approach. I think it's good to think with heuristically, because if in fact we don't affect overall mortality, and we're only pushing around the morbidity curve, then what are we here for?
Full chemistry data? You're right. I think that it would be good to.
That was part of the challenge to the eco-scientists who came along on that trip. We're here to bear witness to human decline and to the suffering that goes along with it. You're not going to save this patient. You're not going to stop this patient from being sick. In Latour's words, Gaia is not sick. Or if she is sick, you're not. It's a terminal illness. We can, at best, palliate this person's suffering, but what we can do is bear witness to the demise of this ecosystem.
Are we in so deep that there's no hope whatsoever? I'm a person of hope. It's a personal commitment of mine. I think that the way out is going to take easily as long as it took us to get here, which will mean 500, 600 years, right? I mean, like that, it's reasonable to think in this way, right? It's going to take us at least as long to get out of it as it took us to get into it. It's probably going to take us a little bit longer. One of the challenges of our culture today is that we're instantaneous. We want things fast. And so when we learn that there's a problem that is really big and that easily is going to take 400 or 500 years to resolve, we throw up our hands and we say, well, it's just not worth it. That's culture. That's culture. But there are other cultures on the planet that have an ability to think in terms of long periods and have the ability to plan in terms of long periods. We have on this planet wisdom from communities that can help us understand what it is that we need to do to change the road that we're on. The First Nations communities of North America have the concept of 7 generations. When you make a decision in the present has to be evaluated based on its impact on the 7th generation. So, we can count, who is that? It's me, my child, my grandchild, my great-grandchild, so my kid's grandkid, my kid's great-grandkid, my kid's grandkid's grandkid, right? We're talking, you think in terms of those people as you make decisions. And you think about the wisdom of 7 generations past. So you think about the advice that you got from your grandparents' grandparent. And you use their input in making a decision today, which is weird, right? We don't think about the wisdom of people in 1780 as we make political decisions. But this concept of 7th generation helps us realize that we should actually know what people were concerned about at that time, what they saw as the threats and the dangers or the wisdom, and we should be making political decisions now for 7 generations in the future. And so we know that humans can do this. Just because I need things instantaneously doesn't mean that it's natural that humans are like that. This is culture, and we can learn from and incorporate the wisdom of other cultures. And in fact, I think it's the only solution.
But getting everyone on the same page to think that way.
It's going to either be the hard way or the really hard way. The hard way is, actually doing this in terms of education, in terms of the stories that we tell. This is also why I think maybe poetry will save us, maybe art will rescue us. These things are ways of imagining different relationships. And this is where I think artists really, really, really have a very important role to play. To step in and create art that helps us imagine a different world. It's hard, but it's easier than the hard way. The hard way is war. It's a contest over scarce resources, and it implies human suffering and non-human suffering. I like the hard way rather than the hard way. I like the way that pays attention to art, that pays attention to the classroom, that pays attention to spirituality as a way to rethink relationship to human and non-human life. I think this is really important, and that's the road that I would prefer.
Both Eric and I have teenagers who listen to scientists tell us how doomed we are, right? And that their very young age to imagine what the world could look like when they're our age is really hard. And you just put forward a beautiful story that I was telling Dan about when you talked to Jed and I, right, about different way to think about what does the critical zone look like. I wonder if that might be something that you guys could help us think through, right, when we are parenting and trying to help our kids understand what their role might be in this strange future. I would love to bring my kid out here, right, and have her hear you.
Bruno asked me initially, why are you here? Right. I think another way to answer that question is to prove that a restorative relationship with the environment is possible, right? And it's not just possible, we're doing it. And the end game isn't just neutral, right? I think that's sometimes the messaging that we get is the best we can do is abstain from harm. But what if we could actually do something that would be positive and restorative? And can we model that? We don't have the tools to fully thrive in the Anthropocene.
We don't.
I don't think so.
That's bad.
But
Why?
Why?
Why don't we have the tools now? Why can't? Is it because the Anthropocene is so new? You got the concept of it?
I mean, I think we have the tools. Maybe like inside, I believe we have the tools, but I don't think we've done a very good job of manifesting them. Or possibly we have them and we don't use them. I don't know. We've understood climate change for several decades now. More and more, the severity of this new paradigm is apparent, and yet just understanding those facts hasn't been enough to get us to alter our fundamental relationship to the earth or to each other. So that's what I mean when I say it doesn't, if we have the tools, we haven't pulled them out yet. And my best guess is that we need new tools that we haven't thought about yet. Not just tools, but practices.
The land has not recovered. The soil is not there. So this is a dramatic aspect of everything we want to do with the land, is that the land, yes, but it has been destroyed beyond recovery. If recovery is the right term, we had also a discussion, but I'd like to hear you about it.
The vegetation is just a green blanket, very impressive from the interstate highway, but lift it up a little bit and you can still see all the gullies, and the slave villages are yet to be uncovered. And not only that, the Native American villages up and down the Tiger River are amazingly rich, completely forgotten, almost completely forgotten, yet to be discovered.
I really do like long-term studies, and when it comes to the soil or the critical zone, one cannot just go out and look at it, take a snapshot, and get much of a picture. If one is interested in the human interaction on these systems, one has to devise ways of sampling the system through time, perhaps over decades, maybe even handing them off from generation to generation. It's really quite shocking how little regard we give to long-term environmental studies that are out on the land. And there are hundreds of them, but they're not networked. They mainly persist because of motivations of individuals who are, for one reason or another, really interested in their study that they will hand off to some younger student. We only have 9 observatories in the country, yet our scientific establishment is so huge. We could really marshal lots more observatories in very important places. There's yet to be an observatory in a city, in a metropolitan area. There's yet to be an observatory in a suburb. There's lots of opportunities to pull different communities of scientists together with this critical zone science idea, that there's lots to share in between our disciplines. And I think you would marshal the scientific community if NSF had if the National Science Foundation had that vision.
I think the somewhat desolation of soil screams at us in the way Don and his colleagues have framed their analysis of the Calhoun Critical Zone. And I've not seen that in other cases. In other cases, the human presence is very there, but it's not there as sort of deeply in the soil as here. And also the difficulty, long-term difficulty, very carefully studied, of coming back to a situation which would not be maybe a recovery, but which would be, let's say, remedial. For the politics of the future, it's pretty important to understand and the dire state of the situation, and also how difficult it is to remedy to it. So this was the most interesting aspect for me, and I did not anticipate that it would be that grave, so to speak. We are all in the same boat, scientists, activists, citizens, gardeners, but of course it has nothing to do with a return to the past. And that's what is interesting. It has nothing to do with getting back to the countryside out of which we escape with great satisfaction and immense pleasure. There is nothing more horrifying still than to be back to the countryside.
Thank you for your time.
Good.
Thank you.